Hello, in this video we'll be looking into how to balance an equation by using the data that's given to you with reacting masses. So before we look into the balancing, we need to review some of the content on moles. So in the previous video, I talked about molar ratio and what do we mean by molar ratio. So if a balanced equation is given to you, the numbers that are used in the balancing, these numbers indicate the mole ratio. So this indicates the first equation reacts in this ratio. So 1 mole of C3H8 would react with 5 mole of oxygen to form 3 moles of carbon dioxide and 4 moles of water. Same way in the second equation, you've got mole ratio in that format. So all I'm doing is I'm using the balancing to figure out the mole ratio. Now, in the previous video, we looked into how to solve the question whereby you've been given the masses and you've been asked to find the mass of something else. So there's always a known and unknown, and I've given you simplified steps. So you just have to do 3 steps to get the answer. Now you can use the same steps to find out reacting volumes and even titration questions. So it's very useful to have a scaffold or have a kind of a frame that would help you to do the calculation. So a quick review of what we had looked in the previous video. So before you do the 3 steps, you need to identify what's the data. Then you find the moles of known. In this case, we found moles of calcium. Then you use that data to find the moles of unknown, the mole ratio, because the balanced equation is given, you know it's 2 to 1. So moles of oxygen is going to be half the moles of calcium. And then the last step is the easiest one to remember. You find the answer to the question. So this is something that we've done in the previous videos. If you found that you're a bit shaky on this concept, then I would recommend you watch the previous video on reacting masses calculation before you progress on to balancing equation when the data is given in terms of masses. So this was the review of the previous content. In this video, we're just going to use the masses, but this time we're going to find out the balanced equation. So we're not going to use our trial method whereby you say, okay, this is how I balance the equation, but this time we're going to use some data to balance the equation. So the data given to you would look like this. So in this question, they've said sodium nitrate decomposes to give you sodium nitrite and oxygen gas. That's the data. When 8.5 gram of sodium nitrate is used, you get that much amount of sodium nitrite and that much amount of oxygen. You've got to use this data to construct and balance an equation. So this time you've been given masses of everything, and now you have to find the moles. So in a way, you're working backwards. So in the previous set, we had found the mass of oxygen, but this time you're going to work backward and you're going to use the masses to find the mole ratio. So again, as before, I'm using very simple steps. The steps are slightly different and I'll explain to you as we go along. So the first 2 things are the same. You write down the balanced equation. So you extract the data, sodium nitrate forming NaNO2. So that should have been NaNO2 plus oxygen. So you extract the data and write it down underneath it. The difference here is you've got to find the moles of everything. Everything is given to you. So you've got to find moles of each and every element or compound that's there in the equation. And I've just done here, same formula, mass over mR, and I've found out the moles here. Now the next step is you've got to find the simplest ratio. Remember, this is similar to your empirical formula type calculations where you have to find the simplest ratio. It's okay if the moles are all in fractions. If all of them are in fractions, it's fine. You can then find out the simplest ratio. So you divide all by the smallest number or you simplify it further and you get this number. And this is the number that can be written in front of the balanced equation or in front of the chemical equation to balance it. And as we know, we never write down the number. So this should have been 2, but we don't write down the number 1. So your balanced equation, you leave it in that format. So this is in a nutshell of how you balance an equation if the data is given to you. So you are given the masses, you've got to balance. And as before, you can go in, double check if you've balanced it correctly. So this has got 2 sodium is right, 2 nitrogen, I've got 2 nitrogen, 2 times 3, 6 oxygen on this side, 2 times 2, 4, and 5, 6, my oxygen is balanced. So it's a very nice question whereby you know the answer and you can double check. So let's try another one. You could pause the video here, and but if you need the steps, so here you go, I've given you the steps. I'm going to write down the equation here. You could now pause the video and find the answer. And if you had paused the video and if you've come back to check the answer, let's try it out here. We're going to find out the moles of everything. This should have been the atomic mass, relative atomic mass. So we found the moles, we divided by, we try to simplify it. So we get the moles of everything 2:1:2. So when you balance the equation, you get that and you drop the 1. So you don't have, you no longer write 1, you can double check 2 copper, 2 oxygen on this side, 2 oxygen on the other side. The equation is balanced. You can try another one here now. So you could pause the video, but if you want the steps, you've got the steps here. You could pause the video now and solve the question. And you could actually check your working out by checking the balancing. So even before you restart the video, you confirm whether your answer is correct or not. If you have just come back after checking your answer and solving it out, so this is how you would have solved the question. You would have got moles like this. So you've figured out the simplest ratio, and we would then write here 2:1, so your answer comes in that format. So well done, so far so good. Let's try a little bit more challenging question. So here you go. So you could pause the video and then come back to check if your working out is correct. And if you have come back just now after completing your work and confirming by balancing the equation, then here goes. So double check your work. But in this question, this was slightly different. You were not given the data for carbon, but we know from the conservation of mass, the mass of reactants should be equal to the mass of products. All I've done here is taken the mass of the products here and subtracted it from the mass of the reactant. Then you would just find out the moles of the reactants and products. So I found the moles here, but the problem is you have now got 4.5 and this is another 4.5, but the other numbers are whole numbers, so it would be useful to just convert all of them into whole number. I can do that by multiplying all of these by 2. So when I multiply 3 by 2, I get 6, 4.5 becomes 9, 6 becomes 12, and 4.5 becomes 9. So I've got that number. Now I just need to simplify the mole ratio. So if I divide all of them by 3, because I can't divide it by 2, so if I divide it by 3, I get the simplest whole number ratio, and that's the number that I can use to balance the equation. And once again, you can double check whether your answer is correct by checking if the number of moles or of atoms. So the last challenging question here. So well done for persevering. So let's see if you're able to get this question correct. So you could pause the video, but if you want the structure, the calculation strip, so here goes. So you can pause the video and then come back to check. And if you had paused the video and if you've just arrived, so let's see the calculations. So that equation was given to you. It's a hydrocarbon. The data in this case, it was given to you as 0.01 moles. So we've just extracted that. Oxygen is not being asked, so we just have to find out the balancing numbers for carbon dioxide and water. So we're not going to worry about oxygen here. We found the moles of carbon dioxide and water in that way. And then you just have to simplify it by dividing it by the smallest number. So you get that answer. So you just write down those numbers 4 and 5. But we can use these numbers because that was X and that was Y. So you've found that you've got the number 4 and 5 there. Now we can also use this data to actually figure out the answer for how many hydrogens I've got there and how many, what is the value of X and what is the value of Y. So I hope you've understood so far what we were discussing here. So it's all about how we balance an equation by using the reacting masses data. So you can work backwards by starting with finding you've been given the masses and you have to convert each of the masses into moles. So that's how you do the question, and I hope you've understood it, and thank you for watching this video. All the best, and I hope to see you at the next video. Don't forget to like and subscribe. Thank you. Bye.